All right, so we are looking at some introduction to probability. We'll spend much more time on this in Math 212. You'll get an entire chapter of this. We're just giving you kind of a nice overview, enough to kind of get through praxis. So probability is the likeliness that an event will happen. We are going to define it as the probability of event. Whatever event is what you write inside those parentheses. So that doesn't mean P times event. That means the probability of this event, whatever that event may be. How we're going to write this mathematically is the number of things you want to happen, favorable outcomes, over the total. And so we're going to look at an example down at the bottom, and then we're going to really do more of an in-depth example. But just some overview things about probability. Typically, it's written as a fraction or a decimal, but it can also be written as a percent. And then there are two extremes. We have this idea of an impossible event or a certain event. So an impossible event is going to sound just like it is. An impossible event is going to be an event that will never happen. It has a probability of 0 or 0%. A certain event is going to be on the other extreme. It has a probability of 1 or 100%. And so some examples of this, I know it's hard to kind of wrap your head around impossible versus certain. An impossible event would be the probability of rolling a 7 on a standard 6-sided die. There is no 7 on that die, and so the chance that rolling a 7 would happen would be 0 or 0%. Versus the probability of rolling a number 1, 2, 3, 4, 5, or 6 would then be a certain event, because no matter what I roll, it's going to be one of those numbers, 1, 2, 3, 4, 5, or 6. And so that kind of gives you some examples of an impossible versus a certain event. We also have this idea of dependent and independent events. Dependent events are going to be just like it sounds. They're going to depend on each other. And so our first example, or just an example, drawing a ball without putting it back, you will draw another ball out of this bucket. And so one scenario, if I reach my hand in the bucket and I draw this yellow ball, I take it out, and then it says without putting it back, I draw another one. Well, now I don't have that yellow ball, so that's going to change the probability of everything else inside. Again, we'll look at this more in detail, especially in Math 212. But just to give you an idea, anytime you see something about without, like you draw a card, you don't put it back, draw another card, draw a sock out of a drawer without putting it back or without replacing, those are going to be kind of your clues to a dependent event. Independent events are going to be the complete opposite. Probability will not change the other event. So flipping a coin, rolling a die, spinning a spinner, drawing a marble out of a bag, and then replacing it, those are all going to be independent event examples. And then our last definition, the complement. Complement is going to be almost the inverse of one event. So for instance, I think it's more, it makes more sense to see an actual example. So we've got roll a 6-sided die. Event A is rolling an even number. Okay, so the possibilities of numbers I'll get on a die is 1, 2, 3, 4, 5, or 6. We call that our sample space. Sample space just means list out all the possible outcomes. And so if I roll a die, I'm going to get a 1, 2, 3, 4, 5, or 6. Well, event A is the even number. So over here in event A, I want to write down the even numbers. 2, 4, 6. There's more even numbers, but I can't get them on my die. And so the numbers that I could possibly roll that are even are going to be 2, 4, or 6. The complement is going to be everything else. So the complement of that, 1, 3, 5. What this means is if you take event A and its complement and you put it together, you then will have the entire thing. Another easy example about the complement is rain or sun. It's either going to, on a certain day, it could be rainy or it could be sunny. And so the complement of sunny would be rainy and vice versa. So here's our example, just a very standard basic probability problem. What is the probability of rolling a 2 on a standard 6-sided die? So we already have our sample space here, 1, 2, 3, 4, 5, 6. And so the probability of rolling a 2 out of the possible outcomes, well, there is 1, 2, and so the probability of that is going to be a 1 out of the total of 6. Now, the reason it's 1 on top is because I want the 2 out of a total of 6. We can leave it as a fraction, or we could write that as a decimal. We will do it both ways when we do an example. And then the last theorem we have, theorem of the probability of 2 independent events occurring is going to be the product of the 2 probabilities. And so it's going to be A, probability of A times probability of B. Now, your key here is this word and. And so where you see the probability of A and B, we're going to multiply. Now, we're going to look at this example in class. I just wanted to give you all of these definitions so you could have that already filled in so that when we go to do this example, these examples, it will, hopefully this stuff will start to make some more sense.